Welcome to Ms. Parv's Flipped Classroom. We talked about factoring with grouping in our previous lesson. In this lesson, we're going to be talking about factoring trinomials of the form ax squared plus bx plus c, which is a quadratic trinomial. And the objective is to factor trinomials in this form using what's called the AC test. So we're going to think of this just as you can write 6 as the product of two numbers, because 2 times 3 is another way to say 6. You can write some trinomials as the product of two binomials. And our first example, we have ax squared plus bx plus c, and the problem we're going to work is 5x squared plus 11x plus 2. So comparing these, we see that a is 5, b is 11, and c is 2. And this always has to be written either as an expression the way it is here, or if it's an equation, this should be equal to 0, so that all of this is on the same side of the equation. Okay, we know that this polynomial has 3 terms, and we want to find a helpful way to rewrite b, the middle term, which is 11x, into 2 terms. Because if we can change this from 3 terms that don't have a greatest common factor to 4 terms, then we can possibly use grouping to factor. So we want to rewrite this as 4 terms, but we want to make sure that it's in some manner that's helpful. So to do this, we do what we call the AC test. And the AC test is what multiplies to give us AC and adds to give us B. So as we said, A is 5, B is 11, C is 2. So A times C would be 5 times 2, which is 10, and B is 11. So if I look at the factors of 10, I know 1 and 10 and 2 and 5. Well, 1 times 10 gives me 10, and 1 plus 10 gives me 11. So we want to use these 2 factors to rewrite 11x as 1x plus 10x. So our problem was that we want to factor this polynomial. We decided that we would rewrite 11x using 10x and 1x. So when we rewrite this middle term with 10x plus 1x, we now have 4 terms instead of the 3 that we started with. So now we can take these and group 2 terms at a time, just like we've done before with our factoring with grouping, and look at just these 2, just this binomial, and we see that the greatest common factor for this binomial is 5x, so we factor that out. The greatest common factor for this binomial is just a 1, so we go ahead and put the 1 there so we don't forget about it. And then when we look at this, we have the greatest common factor of x plus 2 in both of these. So we factor out the x plus 2, and we multiply that times what we have left, which is the polynomial 5x plus 1, to give us our answer. So the only thing new we're adding is we want to use the AC test so that we can rewrite this middle term. And then once we've got 4 terms, everything we're doing is just like we did before in factoring with grouping. Okay, here's another example. Notice that we have a subtraction in this one, so we have to watch what we do with the signs. Our AC test, 3 times negative 15 gives us a negative 45, and our B is a positive 4. So we want to find a pair of factors that multiply to give us a negative 45 and add to give us 4. And I've written down some of the factors of 45 here, and the only one that gives us a negative 45 and a positive 4 is a negative 5 and 9. So we rewrite the 4x as 9x and negative 5x. If we were to add those together, we'd get that. So we haven't changed anything but the way it looks. We group it, take out the greatest common factor on this term and the greatest common factor on this expression, and once again, the expression in the parentheses is the same, so we can factor that out, and then we have 3x minus 5 left as our answer. Here's another example. Both of these are minus, so our AC test, 2 times negative 7 is a negative 14, and our B is a negative 13. So this time we want to know what will multiply to give us a negative 14 and add to give us a negative 13. And some of the combinations are here, and the only one that works is a positive 1 and a negative 14. So we rewrite negative 13x as 1x plus a negative 14x. Group the first two terms, group the last two terms. In these two we can factor out an x. In this one we factor out a negative 7. The expression in the parentheses is the same. So we have 2x plus 1 times our x minus 7. And all of these you can check by multiplying this back out. 2x times x, 2x times negative 7, 1 times x, and 1 times negative 7. And if you multiply this back out, you will get the polynomial up here that we started with. Okay, this problem is just a little bit different in that it does have a greatest common factor. It's easy to forget, but this should always be your first step, is to step back and just look at the problem and see if there's something that will divide evenly into all three terms before we do anything else. And in this case, the answer is yes. All of these numbers are divisible by 3. So we factor out the 3, and that leaves us 6x squared minus 11x plus 4. Now we're going to work with this polynomial, and we're going to keep the 3 in the problem, but we're basically going to ignore it. So A is 6, C is 4, B is a negative 11. So we ask ourselves what multiplies to give us 24, and we'll add to give us a negative 11. And we write down some of the factors of a positive 24. And we see that a negative 8 times a negative 3 gives us a positive 24. And when we add a negative 8 and a negative 3, we get a negative 11. So we're going to use these two factors to rewrite negative 11x. So notice this is exactly like this, except that instead of the negative 11x, we replaced it with the negative 8x and a negative 3x. Group these two, take out your greatest common factor for these, which is 2x. Take out your greatest common factor for these, which is a negative 1, because that's the only thing those have in common. In your parentheses, you have 3x minus 4 on both of these, so we factor that out. And then we'll have 2x minus 1 as our other binomial. So the final answer is the 3 that we've been bringing down, the 3x minus 4 that was in our parentheses that we factored out, and the 2x minus 1 that we had after we factored this out. And this is completely factored. This is the prime factorization for this polynomial because it cannot be factored any further than that.